Okay, number 9. 9 is a log equation with a minus, so we're going to use the quotient property. Quotient property says I can condense it as one logarithm, so natural log of x plus 2 over x minus 1. And now it's a log equation equal to a number, so I'm going to put it in exponential. My base is e, so e to the first power equals x plus 2 over x minus 1. Now I just need to solve that equation. So I'm going to multiply both sides of the equation by x minus 1. So on this side I'll distribute the e, so it's ex minus e to the first equals x plus 2. Again, on this side that goes away. I'm going to collect the x's on one side, so I'm going to subtract x, and I'm going to add the e. Remember, e is just a number. I collected the x's over here because they're common, so I'm going to factor that out. And the reason I do that is now I can divide to get x by itself. So x is going to equal e plus 2 over e minus 1. And that's all you can do without a calculator. All right, number 10. 10 is a little bit tricky because you have two bases raised to powers, and you can't get those bases to be the same. So what we need to do then is we need to take common or natural log, or log of any base technically, but probably common or natural log of both sides. I'll do common log because that's probably what most of you do. All right, the reason I did that, I know if these two things are equal, then their logarithms have to be equal, as long as the bases are the same. So now I'm going to use the power property. I'm going to bring the two powers out in front. So I'm going to get 2x minus 1, that quantity, times the log of 6, equals that quantity, x plus 2, times the log of 3. So now I just have to solve for x. So to do that, I'm going to kind of unlock those from those parentheses. So I'm going to distribute. So I get 2x log 6 minus log 6 equals x log 3 plus 2 log 3. And I'm going to do just what I did in number 9. I'm going to get the x terms on one side, so I'm going to subtract x log 3 on both sides. I'm going to add the log of 6 to both sides. And again, the reason I did that is now I can factor out an x. So I get 2 log 6 minus the log of 3 times that x. And then I can divide. So x is going to equal log of 6 plus 2 log 3 over 2 log 6 minus log 3. And again, that is a totally acceptable answer. You know, if you wanted to condense this, you could. You could say this is the log of 6 times 9, because you bring that 2 up in front. So you really would have the log of 54 in the numerator, over, this would be 36, because that would bring up the 2. So the log of 36 minus, which means you divide by 3. So 36 divided by 3 is 12. So you really could write the log of 54 divided by the log of 12. But again, if you've got this far, I don't know if I would, on a test, finish it off and try to condense it. If I were going to throw it in the calculator, it'd be a lot easier to put that in to check it than it would be to type that in. But they're equivalent answers. So this answer is totally fine. All right, number 11. 11 and 12 both, actually, you should notice are quadratics. So if I were going to let this be my squared term, so 3 to the 2x is u squared. That means u would have to be 3 to the x. And so when I look at this problem, this is 3 to the x plus 1, which really means we have to think of that as adding, you know, when you're adding exponents, you are multiplying like bases. So I'm going to think of that as 3 to the first times 3 to the x. Hopefully we all agree that's still 3 to the x plus 1 power. The reason I did that is now I can think of this as u squared. This I can think of as plus 3u and then minus 4. So this is my u term, that's my u squared term. So now it's easier to factor this. It's u plus 4, u minus 1. And then I set u plus 4 equal to 0, u minus 1 equal to 0. And then I just substitute this back in because I don't really care what u is, I want to know what x is. So if 3 to the x equals negative 4, well, that can't happen. You can't have an exponent equaling a negative, an exponential. If I put in 3 to the x equals 1, I ask myself 3 raised to what power gives me 1? That would be 0. So my only answer is 0. So you need to recognize that as a quadratic and recognize this means 3 times 3 to the x. All right, with this one, we have to do a little work before we see it's quadratic. We multiply by 2. We think of this negative x as 1 over e to the x. And then we realize we have to get rid of the fraction. So that's where we multiply by e to the x. When we multiply like bases, we add the exponents, and that's where you should recognize that you get a quadratic. So we add the 4e to the x, so it's e to the 2x, a plus 4e to the x, minus 1 equals 0. So now again, this is my squared term, this is my u term. So I'm going to let u be e to the x, then u squared is e to the 2x. Which makes sense, then this would be u squared minus, or plus 4u minus 1. And this one doesn't factor. So this one I have to use quadratic formula. We'll start with u. u is going to equal the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. So I'm going to get u is equal to negative 4 plus or minus the square root of 20 over 2. U is going to equal negative 4 plus or minus, this is 4 times 5, so 2 radical 5 over 2. So u is equal to negative 2 plus or minus radical 5. But remember, I don't care about u, I need x. So u is e to the x is equal to negative 2 plus or minus square root of 5. E to the x cannot equal a negative, so negative 2 minus radical 5 is not going to work. So I only have to worry about the plus. And so then if it's an exponential, I put it in log form. So log base e, natural log of 2 plus the square root of 5. And since square root of 5 is bigger than 2, that will be a positive answer. That equals x. So natural log of negative 2 plus square root of 5 is equal to x. All right, 13. I have logarithm, but their bases are different. So I'm going to use the change of base. Anytime the bases are different, you have to use change of base. So log of x over log of 3, log of x over log of 9. Now the reason I did that is 9 is actually, and I'm going to write this as 3 squared. That's what 9 is 3 squared. So if I use the power property and bring the 2 out in front, this is really 2 times the log of 3. So that means to get a common denominator, I have to multiply that by 2. So I'm going to have 2 log of x plus the log of x all over 2 times the log of 3. And again, I know that because 9 was 3 squared, I can use the power property and bring that out in front. So it's 2 times the log of 3. So I multiplied that by 2 over 2. All right, now I have to solve this equation. I would probably get rid of that denominator. So 2 log of x plus log of x is equal to negative 2 log 3. So we use our properties of logarithms. So I would bring that 2 up in front, that's the log of x squared, plus, so that's times x, equals, bring that up front, that's going to be log of 3 to the negative second. So I get here the log of x to the third, so x to the third has to equal, that would be 1/9. So to solve for x, I just take the cubed root of both sides. So x is going to equal the cubed root of 1/9. So with that one, again, we had to use change of base. Be careful if those bases are different, use the change of base. So then we worked with it so that we got the common base that we could add them together, got rid of that fraction, used our properties. We used the power property to make that x squared and that to be 3 to the negative second. We used the product property that says when we're adding 2 logarithms, we combine it as their product. And then once we set those 2 things equal, we had to take the cubed root to solve it. Okay, last one I'll do on this video. Looks like we can get common bases of 2. So 2 to the x plus 1 times 2 to the third raised to the negative x equals 2 squared. Here we're going to add the exponents to keep the base. So if I have x plus 1, and this would be a negative 3x when I multiply those. So negative 3x plus x would be negative 2x plus 1. and then I set those two equal to each other, subtract 1, divide by -2. And when I put that back in, that's exponential, that would be fine because the domain is all reals. So that's page 2.